All right, let us look at a few examples. It's not going to be a few examples, but it's going to be a lot of questions that you are going to look at. Some of them will require us to derive. Some of them will require us to use the general formulas that we have derived in the above video. Right, now the first one says evaluate the following. A triple integral 16z dv. R is an upper half of a unit sphere. Now, working the solution out of this, you first need to understand what is a unit sphere. A unit sphere is an equation of the form x squared plus y squared plus the z squared, which is equals to what? Is equals to 1. Right, a unit sphere. So let us draw our region. So if you have something that is a sphere, by the way. This is x, y, and z. Now, what is your rho? Your rho is the distance from the origin of a sphere to that point. And then we understand that this thing here, it's actually going to be rho squared is equals to 1. So rho is actually going to be 1. And the boundaries for rho 0 and 1. Right. Now, what will be your value of theta? Now, to get the value of theta, we need to draw the xy plane. Now, in the xy plane, what do we see when we come at the top view? You will see a cycle. Right? We will see a cycle. A full cycle, by the way, rotating until there. So your minimum value of theta, your minimum value of theta is 0 to 2 pi. And then this is x, y. And then to get your value of phi, we need to use one of these equations here. We will actually going to get an idea, but we cannot use the tan one. We cannot use the tan one, but we can use one of the equations that we see there. Now, another thing that we need to understand is that we are looking at an upper half. Since we are looking at the upper half, one of these equations must give us pi over 2, but let us use one of them. So since we are looking at upper half, if we draw it here, let us draw the z and let us draw the y. When we draw the z and the y, we will have a curve in that form. Right? So it is 0, that is pi over 2. So your phi will start from 0 to pi over 2. God. Your phi will start from 0 to pi over 2. Now, we actually wrote that down. Whenever we have a positive sphere, your value of phi will always start from 0 to pi over 2. But let us prove it using the equation that I gave you here. I'm just going to use the sine one, so which is going to be the sine of phi is equals to 1 over 0 plus 1. And then the sine of phi of 1, it's actually going to give you pi over 2. Right, so it's your upper bound is going to be pi over 2. Now, setting up the triple integral, it's not going to be something which is going to be hard to do. It's not going to be something that is going to be hard to do because you have written your data down. So let us look at the triple integral. Now, the first thing that you need to know is 16. But what is z? We know that 16z, z in spherical coordinate is rho cos phi, which is going to be rho cos phi. That is z. And then to get a Jacobian is going to be rho squared sine phi d rho d phi d theta, like that. Right? I actually think that everyone followed correctly. Now, since your integral starts with rho, which means your first integral is for rho, your second integral is for theta, then now we are going to take the data and substitute it in. So it's 0 to 1 for rho. For phi, it is going to be 0 to pi over 2. For theta, it is 0 to 2 pi. Now, the way we integrate it, we do not use the whole entire page to integrate this. But the way we do it, we look at the particular function that we have here, which is rho. How many letters do we have, or how many variables do we have there? We have two variables. It is rho and phi. Rho and phi. So we need to group each of the functions with their respective differentials. So we will start with theta. So we are going to have an integral from 0 to 2 pi. There is anything with theta there? No, so I'm going to have d theta. Times an integral from 0 to pi over 2 for phi. Your phi is going to be cos phi sine phi d phi, like that, times an integral from 0 to 1 of rho cubed d rho. Now, we are going to integrate each of these functions independently. But what you need to take note in the middle one is that you can rewrite that function as 1 over 2 sine 2 phi. Because you understand that sine 2 theta is actually going to be 2 cos theta sine theta. If you divide both sides by 2, I get 1 over 2 sine 2 theta is equals to cos phi, cos theta sine theta. So we can rewrite that and integrate that. Now what you can actually do by integrating, everyone knows how to integrate. What is an integral of d theta? That is simple theta between 0 and 2 pi times. What is an integral of half sine 2 theta? That is negative 1 over 4 cos 2 theta between 0 and pi. And then what is an integral of p cubed? That is 1 over 4 p to the power 4 between 0 and 1. And then substitute these things. When substituting for 2 pi, I'm going to substitute 2 pi there times. When substituting pi on that, I'm going to have negative half and then plus 1 actually. Half plus 1 and then plus 1 over 4. Now if you simplify the middle part, which is going to be negative 3 over 4. That is negative 3 over 4. So simplifying this, I am going to have negative 6 pi over 16. So that it is the volume that is bounded. Just know that we are actually talking about the upper part of the sphere. We are actually talking about the upper part of a sphere. Not the whole sphere though, but the upper part. Right. So we are done the first one. The second one, find the volume, find the volume of a sphere having radius r. Find the volume of a sphere, or derive the formula for the volume of a sphere having radius r. Now, we want the volume of a sphere having radius r, so what we need to do, the sphere, right? So if we have a perfect sphere like that, right? A perfect sphere like that, a perfect sphere like that, z, x, y. Like that. So the radius of a sphere, it is r. Radius r of a sphere. So that radius there, it is the same thing as rho. It is the same thing as rho. Right? The radius, it's actually going to be rho. It's the distance from the origin to the outermost part. So your rho, let us set up 0 rho r. Your theta, or your phi, it's 0 to 2 pi. Your phi, it's 0 to pi. Since it's the full sphere, we have seen it here. Whenever you have a full sphere, this is the condition for phi. And then your value of theta, 0 to 2 pi. And then let us integrate. Rho square sine phi d rho d phi d theta. Like that. And then what you can notice is that what is this? What you can notice is that you can actually get your answer very quickly again here. So your rho will start from 0 to r, your phi will start from 0 to pi, your theta will start from 0 to 2 pi. And then if you do the calculations correct, you do not need to do calculations, a lot of calculations, just do a small number of calculations from 0 to 2 pi d theta, since theta is not seen, 0 to pi sine phi d phi, and then 0 to r rho square d rho. Your answer is 2 pi. And here what you need to understand, that is going to be negative cos phi between 0 and pi. And then r, that it's 1 over 3 rho cubed between 0 and r. Now if you substitute it correctly, I'm going to have 1 plus 1 times 1 over 3 r cubed. So 1 plus 1 is 2. 2 times 2, that is 4, which is 4 pi over 3 r cubed. This is the formula to calculate any volume of a sphere. That is the formula to calculate any volume of a what? Of a sphere. So do not get confused whenever you have something that is confused. When they say derive, you need to have something to show them. Right, let us look at another example. I am just going to write it as an integral form. I'm not going to write it as a statement, but let me just write it as a statement. Right, number 3, r, we have x squared plus y squared plus z squared is equals to negative 3 over 2 dv, comma, r is bounded above by a cone square root x squared plus y squared, and bounded below by a sphere of radius 4, which is x squared plus y squared plus z squared is equals to 16. So we need to find the integral. We need to evaluate that integral. First of all, let us draw the region. Let us draw the given region. Right. Drawing that region, I'm going to have a cone bounding it above. A cone, and I am also going to get a sphere bounding it below. So I'm going to have something like that: z, x, y, y here. So whenever, I'm just going to tell you now, whenever you have a cone and a sphere and it's a positive cone and a positive hemisphere, this is the region. You're always going to draw that ice cream cone. You're always going to draw that ice cream cone. So you cannot fail to draw that particular ice cream cone. Please, you cannot fail to do that. You cannot fail to draw that ice cream cone. So let us look at the calculations. Please do not panic when you see crazy functions. For example, since you are given this thing here, that thing there is called a density function. So whenever they are talking about a density function, just know that they are actually talking about the function which is given. There is nothing much that you need to do. So when you are given a density function, you actually need to change it. You need to change the x, y, and the z to the phi x, all the thing. But you actually know that x squared plus y squared plus z squared is actually equals to what? Is actually going to be equals to rho squared. But enough talking. Let us look at the problem solving. Now, how can you determine your value of phi here? Your value of rho. We know that x squared plus y squared plus z squared is equals to 16. X squared plus y squared plus z squared is equals to 16, right? And also we know that x squared plus y squared plus z squared is actually going to give us rho squared is equals to 16. And we always take out rho as a positive. You're just going to take out the square root on both of them, on both sides, and then you're going to get 4, which means rho starts from the origin to the outermost function. I told you that rho is the distance from the origin to the most outer function you have, which is bounded by 0 less than rho less than the square root of a squared. Now, the problem that we're giving here is going to be 16. So the square root of 16 is just 4. So that is the upper bound for rho. So rho will be bounded from 0 to 4. Now, your theta. How is this bounded by the value of theta? Now, we all know that your theta, to see the value of theta, you need to remove the z-axis. Now, by removing the z-axis, you see a cycle, the top part of that cone, which is circular, which resembles a sphere, right? It resembles a sphere. So if you look at polar coordinate, you see that your region starts at this point and end at that point, which means that is a full revolution. So your theta started 0 to 2 pi, right? Started 0 to 2 pi. Now, your value of phi. Your minimum value of phi, it's always 0. But what is that angle there? Now, that angle is measured by using one of these equations here. One of these equations. I always use the arctangent. So to get the value of theta, we will say the arctangent of 1 over the root of square root of 1. What is the arctangent of 1? That is pi over 4, which is 45 degrees. So your maximum value, it is pi over 4. You can actually try sine. What is the equation for sine? It is 1 plus 1, which is 1 over 1 plus 1, which is half. How is this thing right? Half is 30 degrees. 1 over 2, which is half, which is 60 degrees. So it's confusing in this case. So it's better to stick with this one here. It's better to stick with this one. It's going to make this thing much easier. Now I can see. Always they use this equation for tan. Do not use the other two, guys. It's going to confuse you. Or I'm not thinking right. Yeah, sometimes it's maybe I'm not thinking right, but no. Use the one with the tangent. So it's going to be pi over 2, pi over 4. So setting up this integral, first of all, your density functions will be rho squared all to the power negative 3 over 2 times, right? Rho squared sine phi d rho d phi d theta, right? And then what you can notice is that your rho will start from 0 to 4. Your theta, your phi start from 0 to pi over 4. Please confirm the pi over 4 for me. I'm not trusting the calculator. And then your theta is starting from 0 to 2 pi. 0 to 2 pi. So now you can use your maths and evaluate. So again, evaluating this, you don't need the whole mathematics. Just group the terms. 0 to 2 pi d theta, since there is no function of theta. 0 to pi over 4 sine phi d phi, and then 0 to 4. Now let us look at the maths here. it's going to be this 2 and this 2 will cancel out. I'm going to have p to the power minus 3 times p squared, which is p to the power minus 1, which is 1 over p. That is 1 over p. One over p, the rho. Yeah, it's dp or d rho, it doesn't matter. Now calculating this, I'm going to have 2 pi here times negative cos phi between 0 and pi over 4 times ln p between 0 and 4. Now, to do the calculations here exactly, I'm going to have 2 pi times negative root 2 over 2 plus 1. Right, root 2 over 2 plus 1 times ln 4. Because ln 0 is just ln 0 is 0. So that is your answer, by the way. You can simplify it and have something like 2 minus root 2 over 2 if you do it, you're going to have 2 minus root 2 pi. Because this 2 will cancel whatever is in here. It's going to cancel out times ln 4. And if you're going to write it as in mathematics form, I'm going to have something like ln ln 4 to the power 2 minus root 2 pi. That is your final answer. So it's something like that. The decimal place from here, it's the same decimal place from there. It does not matter really. So this is how you calculate it. Right. And then, if you have something like this, this is number 4. Negative 1 to 1, square root, negative square root 1 minus x squared. Let me just write it correct. Negative 1 to 1. Yes, minus it's minus the square root of 1 minus x squared to 0. And we have 3x squared y squared. And there we have the square root of 5 minus x squared minus y squared. And then after this we have 1 over x squared plus y squared plus z squared, or 3 over 2 dz dy dx. We have a problem like this. You don't know what to do. How can you integrate it? A very easy math to do. It is very easy to comprehend that. Now, if you are given a problem in this manner, do not try to panic. Do not do anything, because you're actually wasting your time panicking. Right. But what you need to know is that you need to take out functions first. Now, z is equals to the square root of 3 over x squared plus y squared. That is a cone. And it's something like this. And then z is equals to the square root of 5 minus x squared minus y squared. That is a positive sphere, hemisphere. And then if you have y is equals to negative square root 1 minus x squared, that is a negative cycle. So it's a negative semicircle that is below. Right, so hemisphere, something like this, and then this one, it is something like that. So let us draw our full region. Looking at that, let us draw our full region. So I'm just going to remove whatever is here. Right, drawing the region, it's quite fun because I told you whenever there is a cone in a sphere, what do you get? You will get something like that, right? And then we are going to have an ice cream. Z, X, Y. Now, your phi is measured from this point to that point. Your outer point is what? It is a hemisphere. And you just simply take the square root of that number. So your phi will your rho, is measured from 0 to root 5. Right? Your theta, it is quite different now. Your theta is quite different. Remember I said there was an instruction here that I wrote. I said, if given a problem in integral form, then the last two integrals describe theta in polar coordinate. So, if you take the last two integrals and draw it in polar coordinate, you'll have something like this actually. Right? Which is bounded there, it's bounded there. This one, it is x is equals to 1, negative 1. And then this one here, it is x is equals to 1. Let me just... negative 1. And then this one here, it is the negative square root of 1 minus x squared. So that is the region they are talking about. Now your theta, if you look at this particular region that is given there, your maximum, because the origin starts here to there, your minimum, it is pi, your maximum, it is 2 pi. So take note whenever you're given a problem in this form. So whenever you're given a problem in this form, you need to understand that your last two integral will resemble your theta. And your phi value, only depends on the cone. And then your phi, it is equal to the arc tangent of 1 over the square root of a. And the square root of a is actually the a that is found in your a that you see here, it is found in your cone. So 3, which is going to be pi over 6. So your minimum value of phi is 0, and it's going to be pi over 6, like that. So you need to understand, whenever you're given a problem in integral form, you should work at a different procedure to do this. You should work with a different procedure. So how will you integrate this, or how will you set up this? Now the setup is very clear now. We know that this one here is just simply 1 over p cubed, right? Because we know that x squared plus y squared plus z squared, it is rho squared, right? Which is the same thing as a p. And if we say p squared all to the power 3 over 2, these 2 and these 2 will cancel out. So the entire denominator that you see there is actually going to be p cubed. So now I have 1 over, I'm just going to write it though, 3 over 2 times rho square sine phi d rho d phi d theta. And then what are your bounds? Your bounds are for phi, it's 0. For p, which is the rho, it's 0 to root 5. Your phi, it is 0 to pi over 6. And then for theta, it is pi to 2 pi. So whenever given in integral form, your theta will change. There is no need to remove the z-axis. Just look at your last two integrals and then you will deduce what do you see. And then again, the same principle apply here to simplify this. Pi, 2 pi, the phi, 0 pi over 6, which is sine phi, d phi, times 0 root 5, 1 over p, d 0. This one here is going to be 2 pi minus pi. If you integrate that, the other one is going to be negative cos phi between 0 and pi over 6 times, this is just going to be ln p between 0 and pi root 5, like that. So this is actually going to be pi. Now, what is cos pi over 6? Now, 180 divided by 6, that is just 30 degrees. Now, cos 30 degrees, that is negative root 3 over 2 plus 1 times ln root 5. So, which is the same thing as 2 minus root 3 over 2 pi times ln root 5. So this is another example on spherical coordinates system. Examples. So I don't think that you will struggle much now, because we have worked with those who will make you cry. But last one. The last one is going to be quite long. So it's going to be number 5. If I'm mistaken, it's number 5. Number 5. Even they wrote D, it's still, you can, if they write D or R, it does not matter. So I'm going to have e to the power negative x squared minus y squared minus z squared, all to the power (3 over 2) dv for r is bounded by a sphere x squared plus y squared plus z squared is equals to 1, and x squared plus y squared plus z squared is equals to 4, which is in the first octant and which is above bounded by a cone x squared y squared is equals to z squared. So You'll have that. You will have that. And think, and an example, this is an easy one. Yeah, this is an easy one until you notice that there was an instruction that I gave you here, because I need to do everything that I told you. If there is a cone or cones, your P will remain different, will be different. Actually, it's not cone, it's sphere. If you have spheres, two or more spheres or two or more cones, your phi will be different, because now we want the volume that lies between the spheres or that lies between the cones. We want that. So when we draw this, another thing that is must be considered, it is the first octant thingy. When we say we are at this first octant, we mean we are on the first quadrant in the z-axis, in the xy plane. Right. We know that the xy plane is something like this, and it xy, this one is the first one. Now if you draw the z-axis, this is your first octant. That one is your first octant. If you look at the top, you see something like that. So what will you have? You will have a cone of such, right? And then have a sphere, and then again have another sphere, right? So actually looking at that, we're actually looking at two spheres. We want the region that is in between the spheres, by the way. So the region that we are talking about, it is that one. Now, what will be your value of phi? Your value of rho, sorry. Your value of rho will be determined by the two spheres. Now, the first sphere, it's going to be rho squared is equals to 1. The second one is going to be rho squared is equals to 4. So your rho is starting from 1 to 2, because we have two spheres. Remember, rho is determined by the spheres. And then your theta, because this thing is on the first quadrant, so it is something like this. If you look at the xy plane, it's something like this. So it's 0 to pi over 2. So it's 0 to pi over 2. And then your phi value, just take the square root on both sides. Z is equal to the square root of x squared plus y squared, and 1, your a, it's 1. So phi, it is the arctangent of 1 over the square root of 1. Your phi is going to be pi over 4. So your phi is set from 0 to pi over 4. Like that. So, integrating that, I'm going to have an integral of e to the power negative rho squared all to the power 3 over 2. Phi square sine phi, rho square sine phi d rho d phi d theta. And your rho start from 1 to 2. Your phi start from 0 to pi over 4. And your theta start from 0 to pi over 2. So you see, it is very easy. It is a very, very easy thing. Do not forget about the setup. So this one is a long video, right? So now we will rearrange. We will rearrange as normal. Rearranging as normal, we are going to have something like this. 0 to pi over 2 d theta, 0 to pi over 4 sine phi d phi, and then (1 to 2 e to the power negative root cubed r square d phi, like that. So you can integrate this. Now integrating it, this one is going to be theta between 0 and pi over 2. This one is going to be negative cos phi between 0 and pi over 4. This one is going to be negative 1 over 3 e to the power negative 3p between 1 and 2, like that. Now how did I get this one done? This, we just use the u sub, guys. We just use the u sub. Use the u sub. I've done the u sub most recently on these integrals. So we can just do the u sub here and verify my answer there. So what do you get? We get pi over 2, 2 minus root 2 over 2, 1 over 3 e to the power negative minus 1 over 3 e to the power 9. This is your final answer. Do not tell yourself that you have a big brain. Your big brain of yours will actually going to compute this. Please just leave it like this. As long as there is a pi, you are working with spherical coordinate. So that's it on spherical coordinate. You can try more examples on this one, especially these ones. So thank you so much for watching. See you in the next one.